In this Bertaux's hint, we're going to talk a little bit about utility and rational choice. I will not go over this in detail, but I will remind you that you should have understood the discussion in the book about total utility and the idea that total utility rises with the additional consumption of a good. So if this is, for example, let's say it's pizza, and we're talking about slices of pizza, we may find that when we first start eating the pizza, that the additional slices give us more and more utility, but eventually we reach the point, in this graph it's right around here, where we're going to have diminishing marginal utility, and this means that as we continue up the curve, we do get more and more utility, but it's going up at a slower and slower rate. Okay, so the graph for marginal utility that goes with that would look like this. Marginal utility would decrease, maybe it would increase a little bit, but at some point it would begin to decrease with quantity. Okay? Now, if we ever got to the point where marginal utility actually crosses this axis and becomes a negative, then that would mean that the total utility curve was actually turning down and having a downward slope at that point. We can think then of marginal utility as the slope of total utility, which is going to be equal to the change in total utility divided by the change in quantity. Okay, now we're going to be using this concept of marginal utility, and we're going to combine it with the notion of the price, the unit price, of whatever this quantity that we're talking about here is. In this case, we're assuming it's pizza, so the price of pizza. So let's complicate the picture here and presume that we have the choice of eating pizza or drinking smoothies. And here are our unit prices, $1 a slice for pizza and $2 per smoothie. And here we have some data on as we consume 0, 1, 2, and 3 units of pizza, slices of pizza. Here's how our total utility changes. It goes up. And if you're sharp, you'll see that it's going up at a diminishing rate, so we'll get to that in a minute. Same thing here for smoothies, okay? Quantity's going up, total utility is also going up. So the first thing we're going to do is calculate these marginal utilities. So for the first unit of pizza, first slice of pizza, we go from having nothing to having 1, right? And we go from having 0 utility to having 10 total utility. Therefore, our marginal utility of the first unit, the first slice, is 10, and we sometimes call these utils, 10 units of utility. When we go to the second slice, it's going to go from 10 to 18, right here. So we know that that is going to be a marginal utility of 8. Okay, change in total utility is 18 minus 10 or 8. Change in quantity is 2 minus 1 or 1. 8 divided by 1 is 8. Okay, if we go to the third unit, we're going from 18 to 24. So we see that that has gone up by 6. Okay, and let's go over here to smoothies, and we'll see, again, it's going to be not defined for 0. The first unit is going to add 15 utils to your total utility. The second unit adds 28 minus 15, or 13. And the third unit adds 12. Okay, in each case, we are dividing by the change in quantity, but in this example, the change in quantities are always 1, 1, 1. So the denominator is 1, okay? So be careful about that, because in a problem, if the quantity was going up 2, 4, or different amounts, you would have to divide by that change in quantity. It would no longer be 1. So now we're going to be using our principle of rational choice, our utility maximization rule, and that rule is going to be that when we are in equilibrium here, that given it some income, which we're going to set at $4, we have a total of $4 to spend on these two goods. In equilibrium, we'll find that the marginal utility per dollar of one good, pizza, is going to be equal to the marginal utility per dollar of the second good, which is the smoothies. So we have to first calculate the marginal utility per dollar for each of these goods. Pizza is easy because the price is $1. So when we divide the marginal utility by that $1, we're still going to have the same number. So we can simply label this column marginal utility per dollar, and these numbers are still accurate, 10, 8, and 6. When we move over here to smoothies, we're going to have to add a column, marginal utility per dollar, or MU divided by P, undefined for 0. It's going to be the 15 utils per dollar at a consumption level of 1 divided by the price of $2 is going to give us 7.5 utils per dollar for the first unit. The second unit is going to average 13 utils divided by a price of $2, or 6.5 utils per dollar. And the third unit, 12 divided by 2, is 6. Now I'd like you to think about spending your income of $4, $1 at a time, or buying 1 unit of pizza or smoothies at a time. The first unit that you're going to buy is the one where you have the highest marginal utility per dollar. And you can see that the first pizza gives you more marginal utility per dollar than the first smoothie, so you would buy this. Now you've bought 1 piece of pizza, you've spent $1. You still have what? $3 left. Now let's think about the next thing. You could buy your second unit of pizza, which is now only 8, or you can buy your first smoothie, which would have a marginal utility per dollar of 7.5. Now that's still lower than pizza, so you're going to buy the second piece of pizza. Now you've spent $2 on 2 pieces of pizza, and you have what? $2 left out of your $4 income. Now what do we do next? Well, if I bought the third piece of pizza, I would be getting marginal utilities per dollar around 6. But if I bought the first smoothie, remember that was 7.5. So I will now buy a smoothie with my remaining $2. I have now spent all my income. $2 on pizza, 2 pieces of pizza, $2 on smoothie, 1 smoothie. And am I actually at equality in terms of marginal utilities per dollar? Well, let's see. The last I knew I was at about 8 in pizza and about 7.5 in smoothies. Now this isn't exactly equal, and that's because these units are sort of big chunks of units, and we cannot consume 1/100th of a pizza or 1/100th of a smoothie. We have to buy 1 whole unit or none. I'll give you one challenge question here to do on your own. What if your income went up to $9? What decisions would you make then, given this data? So think about that. Here's a photo of one of the major malls in the world. And what I'd ask you to do here now is to think not about consuming over 2 goods, pizza and smoothie, but consuming over any number of goods, N goods, if you will. And think about each of these little stores at the mall as containing something you might want to buy. We have food here. This might be a real estate agent where you can rent an apartment, so that would be housing. You might have utilities for your apartment here. You might have your cell phone store here. You might have clothing here. You get the idea, right? You might even have one of these levels be have a savings bank where you can open a savings account. And you would buy, with your limited income, those things first that you needed the most or that you valued the most. And as you spent more and more money, you would then move down the line to things that were less critical. And once you spent all your money, if you have successfully maximized your utility, it should be the case that the marginal utility per dollar from the first good, let's say your food, is going to be equal to the marginal utility per dollar of the second good, let's say that was your rent, and that is going to be true all the way down the line, dot, 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 until you reach the very last good that you consume. Perhaps you go to the movies at the mall and see a film, and that's the last thing you consume. Okay, so that's our principle of rational choice. And by the way, the answer to the question that we asked earlier with pizzas and smoothies, which was, what would you buy if you had $9 in income? The answer to that should be that you bought 3 pizzas and 3 smoothies. So if you didn't get that answer, go back and take another look at that.